Okay, so we are going to look at crossover of linked genes. So as I put up on the top here what the bullet is from Alberta curriculum, analyze crossover data for a single pair of chromosomes to create a chromosome map showing gene rearrangement in relative distances. Okay, so when we're talking about linked genes, we're talking about genes that are on the same chromosome, like A and B are on the same chromosome. And we've got alleles, A and little a, okay, for the same gene, okay, different alleles. And the crossing over here, the synapsis, the tetrad that forms occurs in prophase 1. You know that already. And if it does occur, then what we can see in the gametes, those that remain linked are here. But the crossing over ones, the ones where we had crossing over between A and B, we refer to those as the recombinants. Let's review Drosophila, which we saw last time with sex linkage. Sex linkage with eyes was on the X chromosome. Well, what is linked here is body color and wings. They are on chromosome number 3. And we're going to denote it B and VG. Now, this is how your book denotes it. The dominant here is B plus for gray. And wings, normal wings, is going to be VG plus. So it's going to be different. The wild type is plus plus. If you've got ebony body, though, that is going to be, or black body, it's going to be B. And if you've got vestigial wings, we write that as VG. Again, wings and body color, here's my wings, and body color are on the same chromosome. So let's do a cross here. We're going to do a test cross, and this is in your textbook. And we're going to cross an unknown wild type, B plus VG, gray body, and normal wings. Gray body and normal wings noted with the plus. And we're going to cross that with a test cross being crossing our unknown with a known genotype, homozygous recessive. Black, and VG means vestigial wings. Tiny little wings, like they're vestigial organs. They're all shriveled up. Well, if the crossing over occurs, we're going to get recombinants. If crossing over doesn't occur, our eggs are going to be linked, B plus VG, B VG. But if crossing over occurs between these two during meiosis, we're going to get recombinants that are going to be B plus VG and B VG plus. Well, when they get together with the sperm, we do a Punnett square with that, we're going to have, these are the different types. Notice that there's only one type of sperm because as we can cross over all we like between these, we're still going to get the same type of sperm. Well, let's say that we do like a whole bunch of offspring, and we notice that 965 are wild type, 944 are vestigial because this egg got together with this sperm most of the time, but some of the offspring, the F1s, are going to be gray and vestigial, gray and vestigial, or ebony and normal wings. Well, let's add this up now. If I add these numbers together, 391 are recombinants out of a total, if I add all this up, out of 2,300. There's my set. Okay, so 391 over 2300 times 100 is 17% is the recombination frequency. And what we're going to see is that we can now put these apart, and we're going to say that B and VG are going to be 17 map units apart. This equals a map unit. If this was further over, if this gene was over here, we would expect this number to be much higher, maybe 600 or 700, and all of a sudden this might change to say 25, and so these genes would be further apart. And this is how we can map a chromosome on the genes, looking at recombinant frequencies. So some terms: map unit, the distance between two genes that produce the 1% recombination is one map unit. Chromosome map, the distance between genes. The further apart, the location is locus. The higher the percent recombination, we covered that. Parent types are chromosomes identical to the parent, they're linked, but the recombinants show the unexpected phenotype, and this is used to determine the distance between the genes, the recombinant frequency. Here's another way of showing it then. B and VG is right here. But what happens if I gave you something else, like the distance between body and eye color? Well, if it's 6%, we could put it here, and we could take 17 minus 8 would tell us that this distance has to be 9, which would be the distance between these two. That's how we're going to map this out. So let's take a look at a problem. Given the crossing over frequency of each of the genes on the chart, construct a map. A to C is 30 map units apart. B to C is 45. B to D is 40. A to D is 25. Well, what we see here is the furthest distance is B to C. So we do that first. So we put that there first. And then we just start playing around with this. Well, B to D is 40. So I'm going to put my D here. That's going to be 40. Okay. I've covered that one now. A to C is 30. Okay, so I guess I'm going to put an A there. That's 30. And A to D is A to C rather. A to C. Okay, and then eventually we get our A to D from this. Okay, as well. So B to D is 40. A to D is going to be 25. That's right, makes 25. Our total is 40, and there's our 30. Now, what do we do here? Well, we just do that by subtraction. Well, we subtract the 2, and we're going to get our 5 map units there. So subtraction will be the last part, and there's our 5 map units. Okay, so what I want you to do now is I want you to work on those practice problems from this section of the workbook. So we're looking at page, just flip this up on my screen here. Chromosome mapping is on page 12. And or page 13 rather, page 13. So do those questions, and we'll go through the answers a bit later on.